Welcome everybody to our demonstration of Proposition 2. In Proposition 2 we are given a point and a straight line segment BC. Then we are asked to demonstrate that there is a subdivision of a line segment containing the point A, which has A as an extremity of one of the subdivisions, and for which one of the subdivisions is equal to the segment BC. Let's take a look at the demonstration of this proposition. So suppose we're given a point A and we're given a line segment BC. From our proposition 1, we know that we are able to construct an equilateral triangle whose side will be equal to the length of the line segment from A to B. Now, we did that by first drawing a circle centered at A and passing through B, and then we drew a circle at B, centered at B and passing through A. The intersection point of one of those circles then gave us the third point of our triangle. And so this gave us an equilateral triangle, ABD. Now we don't really need our two circles anymore, so we can remove those from our picture. But what we do need is, by postulate 2, we have that we can draw two rays, one ray starting at D and passing through A, and the second ray starting at D and passing through B. Once again, using postulate 3, we are going to draw a circle centered at B and passing through the point C. Now, what this circle does is then intersect our ray BD at the point E. Now, from the definition of a circle, because C and E are on the circle whose center is at B, we know that our line segment between B and E is going to be equal to our line segment from B to C. Now, once again, from postulate 3, we want to draw a circle whose center will be at D and who will pass through the point E. Now, what this circle does is give us an intersection point along our ray DA at a new point F. Now, once again, because E and F are both points along a circle whose center is a D, what that tells us is that our line segment DF is going to be equal to our line segment from D to E. Now, from our common notion 3, because segment DF is equal to our segment DE, and because our segments DA are equal to our segments DB, if we remove those two segments, what that means is that the two remaining segments will also be equal. And so what that gives us is that our segment AF is going to be equal to our segment BE. And finally, using common notion 1, because segment BC is equal to segment BE, and because segment BE is equal to segment BF, what that tells us is that our segment BC is also equal to our segment AF. And so what we have is a subdivision of our line segment DF at the point A, so A is going to be an extremity or endpoint of one of the line segments, and for which one of the line segments in our subdivision is equal to our originally given line segment BC, as was to be demonstrated, and I will see you guys in the next video.